Chapter 3, Section C, Question 5. We have a plane that's inclined to the horizontal at an angle alpha where tan alpha is equal to 3 over 4. You know what I'd do right now, but I won't. U goes off at an angle at theta to that. It's going to follow some path. I'll probably just make that diagram a little bit clearer in a second. And so the question is basically find the maximum height. When I've finished that, I'll come back and deal with the second part of this problem because it really is two parts. And I think the question is not clearly answered. Before I do anything over there, I need to deal with gravity. Gravity goes down. It's a vector that goes down at 9.8 meters per second. We need to break it down to its components. And the reason for that is because we really want to not use I and J this way. We'll rather use our I's going up and down here and our J's going perpendicular to the surface. That will lend us to solve a lot more problems in projectiles in an inclined plane doing it this way. Okay, so I want to break this all down. Gravity now is G there. It's going to be G, that's alpha sine alpha, and G cos alpha. So I'll just rewrite this. So sine is 3 over 5 and cos is 4 over 5, and that's because I did Pythagoras on this to find the hypotenuse, and then that's the hypotenuse, that's the hypotenuse. Voila. So I'm looking for S of J at its max height. S of J at Vj equals 0. If V implies if Vj is equal to 0, then Vj squared is equal to 0, which is equal to Uj squared minus 2 times G times S. And that's a G of J, by the way. Okay, so let's just say that. Let's rewrite it actually, just for handy. Like, so Uj squared divided by 2G of J is equal to S, and that's going to speed us up a little. Is that all true? You agree with that? So now, what's U of J? U of J is this bit here. So it's U times sine theta. So it's U times sine theta. Now it's all squared, so that's U squared and sine squared. And then what's G of J? G of J is this, G cos alpha. Cos alpha is 4/5. So we have 4 over 5 times 2 times G. Okay. And divide by that side, it ends up with 5 U squared sine squared theta all over 8G. And that is the right answer. And I'm happy there. Okay. So the next part is a little bit strange, I think. He wants the greatest height of the particle above the surface at this greatest height. So what we've got here is that at this position, we'll just say, no, sorry, at this position here, greatest height, yes. Actually turns out that the greatest height above it is this height. So I just found a little bit peculiar. So that's H. That's our new height that we really want. This is the S we just had up there. So S from there. And I suppose I just need to rearrange the triangle, have a little look at stuff that's similar, and let's see if we can see that. These questions can often be problematic. So what do I know? Well, I know this is alpha. That's probably alpha too. Oh, what do I know when I got an angle in there? Well, then I got 3 identities only. Sine, cos, and tan. Sine is this and this and this. Cos is this and this. Oh, so cos alpha would be equal to S over H, which kind of says that H, which is what I'm looking for, always a good thing to note what you're looking for, would be equal to S over cos alpha. Oh, hang on a second, I know what cos alpha is. Cos alpha is 4/5. So H is equal to 4/5 of S cos theta. Sorry, is 4/5 of S. 4/5 of S. So basically I'm going to multiply 4/5 of 5 u squared sine squared theta over HG. That cancels with that. Doesn't make any sense. Hang on a second. Clown head. That's divided by 4/5. It's divided by 4/5, then it's multiplied by 5/4. Clown head. So that's equal to 5 by the 5 for the u squared is 25 u squared sine squared theta all over 832g. And I remember that's the question. How could I forget? See you later. Thanks. Bye.